I want to evaluate 6C4. My shortcut to 6C4 is you first have to switch it to 6P4 divided by the 4 factorial. That's my shortcut. You change all combinations to permutations. Now, what you now have to realize is 6P4 means 6 factorial, but only the first 4 spots. So 6P4 is 6 times 5 times 4 times 3. Isn't that 4 spots starting with 6 factorial? So 6P4 is the same as 6 factorial, but only go this number of spaces, 4 spaces. The bottom is simply 4 factorial. Factorials mean start with that number and go all the way down to 1. So that's 6P4. This is 4 factorial. Before I start multiplying all sorts of math and making these huge numbers, you should look for cancellations. Those cancel. You should also see that 2 goes into 6, leaves you a 3. Now, if you multiply 3 times 5, you get 15. And a 1 on the bottom, which you don't need. So the answer is 15. To find a combination, you first find the permutation, divide by that second number factorial. It's a nice shortcut to the real formula. Next, we're going to Subway. We get 6 different choices of breads, 5 different choices of meats, and 3 different choices of cheese. How many different sandwiches can you make if you choose 3 meats and 1 cheese? Now, I assume you can only use 1 bread. That's pretty obvious. So in this scenario, we have 3 scenarios, 3 things going on. We have bread, we have meat, and we have cheese. So, for the bread, how many choices of breads do we have? 6. How many breads do we want? 1. Is this a combination or permutation? Do we care what order we choose the bread? It's a combination because we do not care about order on bread, on sandwiches. I don't care how it lays or whatever, it's just bam. 1 out of 6. For meats, how many meats do we have to choose from? 5. And how many do I want? Well, I want 3 meats. And would this be combination or permutation? Do I care what order the meat is on the sandwich? No, I just want to put the meat on the sandwich. It's just combinations. And for cheese, how many cheeses do I have to choose from? 3. How many do I want? 1. So that's also, all these are combinations because you don't care what order they're put on the sandwich. Okay, 6C1. If you have 6 and you want 1 of them, how many ways can you choose 1 from 6? Hopefully you understand whenever you do 6C1, I could do the whole formula, but hopefully you just learn that's 6. Now this one we're going to do some calculations. But the last one, if you have 3 to choose from and you want 1, how many ways do you do that? I have 3 to choose from and I want 1. Isn't there 3 ways? Now, how do you do 5C3? The same as this up here. 5C3 is 5P3, which means 5 times 4 times 3. Don't you start with 5, go 3 terms down? And then don't we divide by the 3 factorial? So this is 5P3 divided by 3 factorial. These cancel. That leaves you 2. So what do we look like we have? 5 times 2 is 10. So does that look like a 10? So don't we multiply 6 times 10 times 3? 6 times 10 times 3. That is 180 ways to make this particular sandwich. If you have 6 breads, you choose 1. If you have 5 meats, you choose 3. If you have 3 meats and you choose 1, there's 180 ways to make a sandwich. Now at Subway there's a lot more than that, but this is an example. You go in with certain things in your brain, this is what you're doing. This is what you feel like, but there's 180 ways to make a choice from the choices you have going in. Okay, how many different passwords can you make if the first 3 characters are numbers and the last 4 characters are letters? So, how many letters are we using? Letters we're using 4, numbers 3. And are we what? We cannot repeat numbers or letters. So, let's think about this. 1, 2, 3, 4, 5. Aren't there 7 spots you're going to fill? So let's say the first 3 are numbers. So how many numbers can you choose from for the first spot? 0 through 9. How many is that? That's 10. If we cannot repeat, can we use, if we chose 3 for the first one, can we choose 3 again? No. So do you understand it's decreasing each time? Okay, if there's 3 numbers, I have 10 choices, then 9, then 8. I'm done with numbers. What are we switching to now? Letters. How many letters do you have to choose from? 26. Next you would have, if you cannot repeat, do you understand the next would be 25? Then 24, then 23. If you cannot repeat, these are your numbers, these are your letters. Now, do you want to multiply all that? No. On the benchmark, here's how you do it. How do you write this? Is this a permutation or a combination for this first piece? Isn't it a permutation? Doesn't that mean start with 10, and how many turns am I going? 3. Doesn't this mean start with 10, go 3 terms? How do we rewrite this one? Well, what do you start with? Aren't you starting with 26? And how many terms are you going? 4. That's how you'd write your answer for this particular one, because I don't expect you to do this math without a calculator. Does that make sense? I have 10 numbers to choose from. I went 3, and the order is very important, permutation. Here I want 26 letters to choose from. I want 4. Order is very important. Now the next question. What if I can repeat? Because it can switch on your test. If you can repeat, look at this. If it can repeat, do you understand you have 10, 10, 10? Because if I could put 999, can't you have 10 choices each time? And then for letters, if you can repeat, wouldn't that be 26, 26, 26, 26? So how do you rewrite 10, 10, 10? Isn't that 10 to what power? 10 to the third? What's 26, 26, 26, 26? Isn't that 26 to the what? So, you have to be able to write it in these forms. Sometimes putting blanks will help, especially on this benchmark. If you can repeat, it's 10 to the third, 26 to the fourth. And you don't want to multiply that all out. If you cannot repeat, it's permutation, because each turn it decreases by 1.